For a constant rate of change, we're looking at the division of integers. We're given that the table shows the change in altitude of an airplane on a descent to the airport. Find the constant rate of change in altitude in feet per minute. So one thing we should notice right off the bat is that we should recognize that the solution, the constant rate of change, is going to be negative because the airplane is descending. We should also remember that constant rate of change simply means, we know the relationship is linear. If it weren't linear, we wouldn't have a constant rate of change. And that we're essentially finding slope. So we can pick any 2 points on here and we should get the same solution. We'll use 1 and 2 to start off. So we want the change in altitude, so delta altitude over the change in time. So delta, and delta just represents change in time. So we'll start with those first two. So 30,000 minus 36,000 over 2 minus 1. That equals negative 6,000 over 1. Just to verify, let's go ahead and pick two more. We'll do 4 and 2. So we have 18,000 minus 30,000 over 4 minus 2. That equals negative 12,000 over 2, which again equals negative 6,000. So the constant rate of change is negative 6,000 feet, because that's the change in altitude, per minute. And again, we know that the solution is negative because we have a negative integer in both instances, or in any of these instances for that matter, a negative integer over a positive integer. If we switched the order, say we had 36,000 minus 30,000 over 1 minus 2, notice that the solution would still be the same because we'd end up with a negative value in the denominator. We'd still end up with the negative 6,000, and that's because a positive divided by a negative is a negative, or a negative divided by a positive is a negative.